So, greetings students, welcome to today's lecture. So, in this lecture, we will be moving towards your, already we have seen about your unit 5. So, in the unit 5, we have already covered about your distributions, right? So, distribution side we have already seen. So, in this, we have to see about various kinds of distributors. So, we will be dealing with your DC distributors in this lecture. And in this lecture, this distributors is also classified in as three types. One is your fed at one end when the load is fed only at a single end. Sorry, not the load, the source. Okay. So next is fed at both the ends. Okay. Next is about the ring main configuration. So it will be just like a circular ring. After that, based upon the loads we will be seeing. So mainly what distributor load and concentrator load. Based upon distributor load and concentrator load we will be seeing. So for example, if you are taking a feeder in the sense from A to B, first you have to know what is a distributor load and concentrator load. If you are taking as A to B means if from A to B point, if the loads are attached throughout your A to B means then it falls under your distributed load. Okay, but at the same time, if the feeders from A to B and the loads are particularly concentrated at a single point called X. Okay, if two or more loads are particularly concentrated at a single point means then this will be called as your concentrated load. So this is the basic difference between your distributed load and your concentrated load. Uh, Distributed load and your concentrated load. So next we will be seeing we'll be getting into your DC distributor. So here first we will be starting with your DC distributor fed at one end. Okay. So here this is the basic figure. Okay, this figure is for your distributor fed at single end. Okay, so here you can see the loads having concentrated loads and fed at one end. Okay, so here at a particular point the loads will be taken out. Okay, so these loads are called as your concentrated loads. Okay, uh, and fed at one end. So the current flow at that end will be I1, I2 and I3 are your load currents. Okay, these will be your load currents. Okay, so here it will be going to the load 1, here it will be going to the load 2 and here it will be going to the load 3 and the specific currents will be I1, I2, I2 and I3. R is the resistance per unit length. Okay, so small r is your resistance contributing to a per unit length. So now you will be need for your voltage drop. So a voltage drop is nothing but simply you have to apply your KVL. So if you are applying your KVL means the voltage drop will be equal to the current flowing from A to C. Okay, this is a I1 plus I2 plus I3. Okay, into uh, this L1, that is the length. This L1 into your resistance per unit length. As I said, for the transmission line, you have to first find the resistance for a particular length, and then finally you have to multiply with that your total length. That is for per unit, we have to take it out, and then you have to multiply with your L1. Similarly, for over here, if you are applying KVL means, so this voltage drop will be the current. So here I1 will be deviated, and here you will be getting only I2 plus I3. And when coming to the D point, your I2 get deviated, and you will be only flowing of your I3. So you'll be getting I2 plus I3 into L2 into R into your resistance per unit length. The same goes for your B point also. Thus, the voltage drop at the far end of the distributor is nothing but the sum of the moments of various currents tapped off. Okay, I think you are able to understand. That is, the voltage drop at your B point is nothing but the summation of all the voltage drops across from your A point to your B point. Okay. So here it is seen that the L1R is the resistance of the distributor up to the point I1 is tapped off. Next it is L1 plus L2 into R. Okay, that is the amount of resistance which is tapped off. They are saying the drop up to any immediate point is equal to the sum of the moments up to the point plus the moments of all the currents beyond that point. So this is the basic concept what I have explained the previous slide. Okay. So next we will be moving to the uniformly distributed load. Okay. So here you can see an example of your distributed load. So as I said, if there is 2 points in the sense from A to B, you can take this is at the A side and this is at the B side. Then what happens is that your distributed load will be shared throughout those points. It will not be concentrated with respect to any particular point. Okay. So here you can see the figure shows the uniformly loaded distributed onion. The current tapped off per unit length is I. So here the current per unit length will be your I. Okay. The total length, okay, the total length of distributor is L. The entire length is L. The voltage drop up to a distance U from a feeding point is. So we are particularly taking a small distance. We will be taking like x dx, right? So more or less similar to that, we are particularly taking a small distance U. Okay, and we'll be finding the voltage drop across that U. So here the voltage drop up to distance U, that is from here to here, will be, that is from the feeding point to the U will be sum of the moments up to the U, that is the sum of up to this load. Okay, up to this load plus the moments of load beyond U assumed to be acting at the distribution thing. Okay, so here what they are saying is they are adding this sum. Okay, they are adding this sum, the voltage drop of this sum plus the voltage drop of the other part. Okay, that is moments of loads beyond U assumed to be acting at the distribution side. Okay, so here the value will be going from 0 to U. Okay, it will be going from 0 to not A, it will be U. So you'll be integrating with respect to U, and now if you're integrating this value means you'll be getting so here there's U there, you'll be getting this value minus 1 by 2 I R U square. So this is the differential part of the U, that is your du. So the voltage drop over the length L is obtained by substituting U, that is replacing U with your L. So this is the same thing what you'll be doing while finding the inductance value. First you will be finding up to the X value, after that you will be replacing the X with your entire length. So you'll be getting I or L square. So because this U is replaced by L, so it will be L square minus 1 by 2 IR L square. So you'll be getting finally 1 by 2 IRL. So this is your total voltage drop. So now moving to the case 3. So in the case 3, you will be making use of both of your concentrator and your distributor load. So in this, it is possible that a distributor has concentrated load at some points and uniformly distributed load at some other point. That is both the type of loads will be there. Okay, so with respect to your concentrated load, we will be considering only for a particular point. But with respect to your distributed load, you will be considering for a range of points. Okay. So here the resistance is R per unit length, and the current will be I. The voltage drop in length L from the point at which the current I is fed is given by from 0 to L or L minus IU du. The same thing what we have used over here. So we'll be integrating with respect to your U, and the limits will be from 0 to L. So you'll be getting RL I minus half IL. So here you can see there will be 2I. So this I represents for your entire current, and this I represents for your particular length. So in the case 4, if the distributor fed at both the ends. Okay. So till now we have seen about your single end distributor feeding, and in this case 4 we will be dealing with your distributor fed at both the ends. That is, from your A point also it will be fed, and from your B point also it will be fed. Okay. The distributor is used when the length of the this kind of configuration is used when the distributor is long and the load currents are very high. Mainly in case of your industrial load, they will be using such kind of configuration. If such a distributor is fed at one end, if you are using a single end distributor, means what happen means the voltage drop along the distributor will be very high. Okay, the voltage drop will be very high. The voltages at the feeding point A and B may be equal or unequal in case of your single end feeding. Okay, so in order to make your voltage drop as a uniform throughout your distributor load, you have to feed from your both the ends in order to meet out your high current expectation. Okay, so in case of industrial loads, we'll be making use of your distributor load which is fed at both the ends. So it is evident that the load current would be supplied partly from A and from B. That is, if the current IA is very small, means at that time IB will be providing the current to the load, and if IB is small, means at that time IA will be contributing to the load. If a uniformly loaded distributor is fed at both the ends, the minimum potential may occur at any point. Yes, because the voltage drop is minimized, right? So it is possible that the minimization of potential is possible in case of your distributor fed at both ends. So coming to the next one is your ring main distributor. So this will be looking like a ring topology. So here you can see. So here the loads will be connected in a ring format. If a distributor is arranged to form a closed loop, so this is the main word, closed loop, it becomes a ring main. It may be fed at one or more points. A ring main and a secondary network are more or less similar. Here you can see it out. A ring main is more or less similar to a secondary network configuration. Such a system has better flexibility and reliability because in case here this is a IA is feeding, right? So IB is feeding. So I1, I2, I3 are nothing but your loads. Okay, L3, L1, L2. So in case if IA and IB, in this IA and IB, if IA falls out, means what happens is that the IB can provide the current to your I2 as well as I1 as well as your I3. Similarly, if IB fails, means IA can do the same operation. So this increases your reliability of the system. In case a fault develops in any one section, it can be isolated from both the sides. So this is what I have explained about just now. Sometimes two or more ends of a ring main are connected through interconnections to form complex network. Okay, so this is in case of a very high network, complex network can be formed by connecting two or more ring mains together. Okay, so this is what with respect to your DC distributors. Okay, so here the important questions what they can ask is brief about DC voltage distribution, types of your DC distributors, what is a distributor load, concentrator load, and they might be asking about explain about your ring main distributor. So these are your possible questions in this lecture. So thank you.